Hi everyone, these are the notes for 7.5 on volume. So the volume I think you'll like a little bit better than surface area. We don't have to draw any nets, so that's cool. So volume is the measure of how much space can fit inside a figure. So how much one by one little little cubes can we stuff inside a figure. You remember area was how many squares can fit inside it in that two-dimensional shape? Well, now we're having cubes fit inside a three-dimensional figure. So depending on what kind of polyhedron it is, we will find the volume in a different way. So if we have prisms, the volume of the prism is the area of the base times the height. So big B stands for area of the base. So area of the base times the height. The volume of a pyramid is similar, area of the base times the height, but it's 1/3 of that. We have to divide it by 3. Because if the base and the height were the same for a prism or in a pyramid, then their volumes, it would be 1/3 of what the prism's volume would be. And lastly, our spheres, just like with surface area, they do their own thing. So it has just a straight up formula. There's no like area of the base because it doesn't have a base. So it's 4/3 pi r cubed. Remember the surface area formula was 4 pi r squared. So we put the 3 underneath it and then we raise it to the 3rd power instead of the 2nd because volume's to the 3rd power instead of the 2nd. So that might help you remember the difference between them and help you remember both formulas. So they're very similar. Okay, so let's take a look at our examples. So you need to figure out, are they prisms or pyramids? And then what is the base? So our first shape would be a trapezoidal prism because the base would be this side right here in the front. That's a trapezoid. I know you don't necessarily see it, but the back part back there, the base or the other side is a trapezoid as well. So that's why it's a prism, because there's 2 parallel congruent faces or bases, and it's a trapezoid. So we're going to do the volume as the area of the base times the height. Sometimes when the shapes are like this, like flat instead of standing up tall, I think of the height more as like a depth, but it would be the same thing. So the area of this times how far back it goes or how tall it is, height or depth. Okay, so the area of the trapezoid is half times the height times the sum of the bases. So remember we talked about that formula back in 7.1. So that would be 2 times 22 or 44. So our volume is going to be the area of the base, which is 44, times the height or the depth, however you want to think about it. So the volume of that trapezoidal prism is 440 centimeters cubed, volumes cubed. Okay, so let's take a look at our next example. This would be a square pyramid. So we need to do the volume is 1/3 area of the base times the height. So let's find the area of the base. So our base is a square, so 3 times 3 would be 9. So the volume would equal 1/3 times the area of the base, which is 9, times the height, which is 5. So remember, for the height, we want the regular height, not the slant height. So if you get the slant height, you're going to have to solve and work backwards to find that regular height. Like on 7.3, or 7.4, how we had to work backwards sometimes to find the slant height. Okay, so what I'd like to do is if I can divide one of those numbers by 3, I'll do that first. So 1/3 of 9 is 3, or 9 divided by 3 is 3. So 3 times 5 is 15. So this would be 15 yards cubed. Very good. Okay, so moving on to our sphere. Our volume is equal to 4/3 pi times r, which would be 2 cubed. So remember, this is the whole diameter, so the radius would be half of that. Okay, so cube things first. So we have 4/3 times 8 pi, because 2 times 2 times 2 is 8. So I put it over 1, so that way they're both fractions. So remember with fractions, we just multiply straight across. So that would be 32 pi over 3 yards cubed. So if you can reduce, you should try, but we can't on that one, so we'll just leave it just like that. Remember, we talked about the difference between leaving it in terms of pi or as a decimal. So for now, we're going to stick with in terms of pi. Okay, so let's do the cone next, because that one's a little bit hard. So, or not hard, but different. So it's a pyramid, so we'll do the 1/3 area of the base times the height. So let's first find our base. So our base is a circle, so that would be pi r squared. And remember, if it goes all the way across, that's your diameter. So our radius is 5. So 5 squared pi would be 25 pi. So our volume equals 1/3 times 25 pi times 12. So 1/3 area of the base times the height. So for this one, since I can take 1/3 of 12, I'm going to do that first. Or 12 divided by 3 is 4. So 4 times 25 pi equals 100 pi. And our units are kilometers cubed. Okay, so I would like you to practice the other 5 that are left. And then when you come back, we'll talk about the answers. So go ahead and pause your video, complete the other 5 examples, and we'll talk about the answers. Okay, so remember, if you didn't get these answers, to make sure you ask questions about it next class. Okay, so here we had a cylinder, so we did the base is 9 pi times the height, and we got 54 pi. For the bottom one, we had a triangular prism, so the base is a triangle times the height, and we ended up with 1,250 centimeters cubed. Here we had a rectangular pyramid, so the base is base times height, so 4 times 10. So 1/3 times 40 times 6, so 1/3 of 6 is 2. 2 times 40 is 80, so 80 centimeters cubed. For the sphere, we plugged into our formula, and we ended up with 288 pi centimeters cubed. And for this one, I did the formula first, as if it was the whole sphere. So I got this. I left the 4/3. I don't know why I wrote it like that. I left the 4/3 as a fraction, but then it's only half a sphere that we have there. So that answer that I got, I times it by a half, because that's like dividing by 2, since we only have half of the sphere. So I ended up with 1,024 pi over 3 feet cubed, because I reduced that. Okay, very good. If you have any questions, make sure you write them down and ask me in class tomorrow, and we'll go over anything you guys didn't understand. Werner out.